and obviously Erdem, productive machines. Obviously Mark's just touched on it, but it would be really good to hear a bit more information around productive machines and how you got involved in this project and the advantages that you brought to it as well.
Yeah, so productive machines help machining companies to produce the best part faster and first time. So we are keen to partner with all the companies in the machining industry, and we have been in engagement with Seco for at least a year now. So we have done proof of concept projects earlier, and we were quite happy to be involved in this project when Mark invited us to be involved, because there's a new material, CFRP, which is quite difficult to cut. There's a new cutting tool, a pineapple cutter. I hadn't seen such a tool before. And what we wanted to do is we want to demonstrate that this process can be developed faster and can achieve better productivity and quality. So in the demonstration that we have seen in the video, we had the data analysis section. So we collected sound data, acceleration data, and the cutting forces data. But after the event, we also did analysis on the material data so that we could identify the cutting force coefficients. Then we were able to run our digital twin, and when we compared the measurements with the digital twin, the results were very promising. So we could see very good correlation between the predicted forces and the measured forces. So which tells us that, for example, Seco can use this tool to accelerate the development time for these tools. And also when Seco works with an end user, like a manufacturer's lead time will be quicker, because all the parameters like speeds, speeds, axial depth, stepovers can be tested in the digital twin environment rather than on the machine tool.
So we know it's going to work before we even know it's going to work.
Yeah,
in my mind that's like a digital prove-out scenario. It's fantastic. There's no waste in like money then as well, so that's great. And I do know obviously this particular cutter we've got, it had its challenges for getting the geometry into your software to actually get the results we got given. So I mean, it obviously looks. The next question is, did you measure the forces created during machining? It kind of fits nicely with some of the problems that you've had or the issues you've had, how you've overcome them. Obviously.
So
answer that question as well.
We measured the cutting forces with the equipment available at the AMRC. So we use the Kistler force dynamometer. So that gives us the forces in 3 directions, X, Y, and Z directions on the workpiece. So we use this kind of measurements to identify material characteristics. There's a very simple process to identify the material properties, which takes maybe 1 or 2 tests, like simple straight tests. And then we have the data needed for the digital twin. So there was about around 20 holes, and we made simulations for all these 20 holes. And in the stand we have the measurements and simulation comparison for 2 representative cases. And you can see when you are going in, the tools are experiencing forces around maybe 20 to 100 newtons in the XY directions. But when it starts enlarging the hole, the forces increases to 300, 500. In the measurement you can see that. But even before you go to the machine, you can see the same thing in the software too.
Okay, good, thank you.